All right. So with this, I always kind of ground people and ground folks that I'm working with, especially new folks coming into this work, what it means for us to grow food and grow seed in our community. I was taught this value system based on what my uncle. I had the pleasure of being able to grow with him. He was a leader in pretty much every capacity you could be in our community, whether that was on the traditional side or on the government side of things. And so that man knew a lot, too much, honestly. And his name was Yainia, and I miss him dearly. He passed away like about over 5 years ago now, but he was a big mentor to me, and these are one of the things he taught me. This is the first thing he taught me when I was growing. I planted with him in our family gardens one year, and I had been we planted and irrigated first time around, and then he noticed I wasn't there for probably over 2 weeks, and then he came to my house, knocked at my door, and basically said, "Where you been, Kawhi?" And I gave him whatever lame excuse I gave him during that time. And what he said to me was that, well, what you're doing right now, that's basically a big no-no of when you said when of our way of life. He said, whenever you told me you wanted to grow, you wanted to have a garden, I thought you were serious. And basically, he told me that you're creating life there. You're those are your children. You're putting your the seed into our mother, Shana Shati, the mother of the land, and you're gonna create life with her, and you're going to make children. And if you ever have children, this is the place you learn how to caretake, learn how to love, learn how to be committed, learn how to be disciplined, and all the things and ways that adult men should be acting in our community. And so he said, whenever you put that seed in the ground, tell me, meaning may all of our children grow, or chitoni, may you grow. And you're basically, committing to about 6 months of work, of hard work, of sacrifice, of putting good intentions and putting all of you into the land and soil and stewarding that land and stewarding those seeds, those children that we're growing. And what he would say is, children, they need love, they need care, they need attention, they need nourishment. And so with that, he would tell me, he scolded me and he said in a very stern voice, you never leave your children. You always take care of them, you love them, you take care of them, you do your best by them. And the more love and attention and care and you put into them, the better off they're gonna be. Just the same as your plants. The more love, care, and attention, you can give to them, the better off they'll be. And he was right. That man showed me up. I made this lame excuse at the end of the season of why my field didn't do as well because I still didn't commit as well as I should have. And his corn was about 12 feet tall and produced like crazy. Had a ton of beans, ton of squash. And when they got into the season, he asked me what happened. And I just told him, well, it was the tree that took up all the water. It was the soil. It was all the this and that, whatever I said. And he just rolled his eyes in his typical manner. And he just said, I guess I grew 5 feet away from you and my corn came out good. I had a good harvest. And so it's because I was there every day, because I sang to them, I prayed to them, I treated them like my children. And so, yeah. But when we're able to see those things, we go through and see the whole season through, you see the cycles of creation, their young age, their adulthood, and their old age, and replicating themselves and creating their own children. So this is a little slideshow that I'm going to show you all just so you can see, like, for me, this is what you go through the whole season, and I document forget what year this was, but it was a while. So you'll see at the beginning, once it gets going, the starting off with the cleaning of the ditches in Acoma, planting of the new seeds, sprouting, the first emergence, our babies coming out of the ground, the summertime, the rains coming, everything fruiting, the flowering, and then you get your first glimpse at your hard work. And eventually you get to harvest if you did enough good work. And you get to taste it and bring home this food into your family or your community. Bring home all this seed, bring home all of these blessings back into your household and share it with your community, share it with the family, and renew the hope of those seeds again. And so I always end with him. This little guy is my nephew, and he was another learning lesson for me. And funny enough, the same year that, or interesting enough, I should say, the year that my uncle passed away is the same year that this little guy was born. My uncle Ron was named Yaina, and so we named this little guy Yaina. So I guess we never really lost him, really, And this little boy, this little one, grew up um, with his mom 9 months pregnant in the field hoeing weeds, and grew up eating the foods of our original foods and playing in the field, playing in the ditches, even when he was just a baby. And I always think about him when we have think about the future, and that's who this work really is for. It's grounded in the future that some of us might not even get to see, a future that we hope for a good future with our young people because this is all for them. This is going to be their inheritance in the same way that these seeds and this way of life, these things that we care and love for so much, we inherited through all of the love, the immense amount of love our ancestors had for us, future generations and children. So this is who it's for and who I think about and who grounds me in this work is because I think of them and the future generation constantly. And to just talk about a little bit of like our how deep our histories go. These items here were taken from Wapaki National Monument, which is an ancestral Puebloan village. It's dated back to from about 1100 to 1200 AD when it was occupied. And these are all remnants of what were excavated of and agricultural tools and such. Wapaki is just about maybe 20 minutes outside of Flagstaff if y'all ever been to Arizona. But anyways, these islands were excavated there, and you can see right here at the top there's stone holes right here. Of course, they didn't have any metal. This is pre-contact, pre-colonization. So there are stone holes right there they created to hoe weeds and dig, and then also digging sticks at the bottom right there for planting and whatever else they needed to moving earth. And you also see these smaller eared cobs, so they're more likely dryland farming because of the smaller ears that they grow. And this site is also known as a area that is very specific to the Hopi people that we're also closely related to. We all live on the Colorado Plateau, so we were always neighbors with each other. But with these items, these discs, I always, was so fascinated by those. So these little lighter colored discs right there, what they are is actually lids. They used raw clay from their potteries and impressed the image of whatever they were storing in vessels like these. So this was a clay pot dated to around the same time from around the same region, and it was used as a storage vessel. So those lids would go on top of them, and they used the raw clay to seal the top of the lid, to seal the top of the pottery, and then they would also seal it up that way just to show what was inside of it. So it's sort of this ancient labeling system, since you don't have a translucent glass jar or anything like that to see inside the pots. So this is an example of another pot dated to around the same time. And it's really interesting motifs on there too. You see cornfields of these little dots and squares. Those usually represent cornfields. And you see the zigzag lines, lightning, rain, all those things, clouds. So which we all, pray for. This is one that my father made for me quite a while back for my birthday. So and we have these same kind of motifs, these zigzags. So you can see the little continuity there of our cultures and our seed keeping ways of life. You see the Taratmish, the dragonfly with rain cloud motifs all over him, and same with all these field and rain cloud motifs all over the pottery too. And mine was being plucked with a corn husk. Um, so we'll get into some key terms and definitions that we're going to be using throughout the presentation. So feel free to take a picture or screenshot any of these things, but I'll be using terms like cultivar, which is basically a domesticated non-wild crop that was bred for specific traits or growing. So it was transformed over time from a wild plant into what we know as domesticated plants. So cultivar, or the plural cultigen. Um, I'll also be using the term genus and species. Those are known as the binomial names. So genus is the family that the crop belongs to, and the species is the specific type of within that same family. So, for example, I'll be referring to as a Hubbard squash, but if I were to use the binomial names, the genus and species to describe it, I would say Cucurbita, which is the family, the genus or the family, and the specific species or maxima. And there's different species of Cucurbitas that I'll kind of go over, but just to kind of give you an idea of what I'm going to be talking about. And these are going to be really important for knowing what will cross-pollinate and what won't. Then there's also the term I use is true to type. Basically, the offspring or the seed is the exact match of both parents and hasn't basically crossed with anything else other than the type that you intended it to grow. And the last one would be hybrid, which is the offspring of two different types of plants that have cross-pollinated with each other. So say I grew a blue corn next to a white corn, and all of a sudden I get speckled blue and white in the next generation. So that's what we refer to as a hybrid, as opposed to a full colored of either colored blue or white. Um, and going to for me why this work is so important, which I kind of briefly went over. So, seed caretaking and seed stewardship. Um, really is about perpetuating life, as Vandana Shiva here states. Those of you that aren't aware of Vandana Shiva's work, they're an amazing person too, an amazing seed sovereignty activist from the country of India. And they saw a huge, you know, tragedy within their country when most of the country basically was kind of outlawed to save seed. And there was a sort of seed monopoly that seed companies had over the country. So they can only place they could get seed because they couldn't save it was from these seed companies, and these seed companies couldn't deliver in time to for the planting. Those of us that are farmers, you have a small window for getting your seeds in the ground before it's too late, before the frost or anything else might get it to lead to unfavorable outcomes or little yields and things like that. So, and the seed companies weren't able to deliver. So that meant farmers across India basically going broke, bankrupt. And this real sad tragedy of that is they were never able to financially recover, and thus led to a mass amount of suicides in the country because people essentially kind of given up hope for sustaining themselves and growing food and things like that. So Venice Shiva took this opportunity to grow local seed banks and local communities and have the be in India to be able to save seed and teach people to save seed and bring to attention the need for seed sovereignty in communities across the world. And so, and seeds, all of these really are the legacy of our ancestors, especially if we come from communities that have culturally, bioregionally specific seeds that have been handed down for generations. I used the example like the seeds you see here in the picture. Those are a dryland variety of a blue corn. Historically, they've been planted very deeply. You can actually plant them up to 12 inches in the ground, and they will still sprout through 12 inches of soil. And it's because they've been planted in deep soils because these are a dryland variety, which will depend on the residual moisture from the winter time, the winter snowmelt. And it will sustain itself off of that moisture in the ground and actually search for water. It has a very deep taproot. And it will sustain itself until the summer rains come, if and when they come, hopefully. And you just need a few good rains, and you should be able to get a good harvest off of it. And this corn right here grew with probably almost 2 months of no water, and it sustained itself and was able to actually grow seed and from that crop. So yeah, just an example of the power of these legacies of these cultivars, these domesticated crops that were selected and saved over time to develop these natural attributes and advantageous attributes that allow them to grow in the conditions of their environment that they've been bred to grow in. We also preserve our traditional diets and recipes. If you know anything about like especially your gut microbiome, all of us have this layer of microbes that live in our guts and our colons, and they really love the foods that our ancestors have been raised on, especially when it's more fiber and more food like this, and it will be linked to like your own health and wellness, even your own mental wellness too. So the more that we consume our original foods, the better off our bodies and minds are, and spirits are too. They preserve, and also I always say this to people: those that control the world's seed, like in the example of India, control the world's food supply. Seeds automatically equal liberations. The act of saving seed, I should say, equals liberation from capitalism and institutional racism. It gives us the agency and autonomy to be able to grow food for generations after us. It's food security for our families and our community. Those of us that have seen, like, for example, I use the story of COVID and communities like mine. We're very rural. The nearest town is about 30 minutes away, and the nearest city is about over an hour away. And so the years, I maybe I should put this clip in here in these presentations one of these days, but I remember the first time I went to Walmart in the nearest town and not seeing any food on the shelves because everybody was hoarding during that time during the beginning stages of COVID. It wasn't just toilet paper, it was food too. So, and I never seen so many farmers that year. Those 9 to 14 farmers every single year in Acoma, Pueblo that I used to see transformed into 75 farmers in that year. So it was an amazing boost of farmers growing that year. And even my former partner mentioned to me that when they were living in here in Albuquerque, outside of the communities, they saw just a huge amount of food coming from Pueblo communities that had were just sharing it with each other. And so you saw this huge, mutual aid work happening essentially. That was just an act of us sharing food. It stories helps us restore a healthy relationship with our plant relatives, our lands, our bodies, our physical, our mental, spiritual health. It's a nourishing activity that's communal, that keeps us, in a happy, grounded place and community. So for me, that's what this work means. And kind of going to go over some of the types of seeds you'll see. So, uh, or actually, I should begin with this. So, when I say cultivar, I mean it's been bred into a what it looks like today. Those of us that aren't familiar with this, for the longest time, scientists and people wondered what was the origin of corn, for example. Where is this non-domesticated species, the wild ancestor of corn? And so all of these species had to be, these varieties, these cultures had to be developed and bred to over generations to be what they are today. So one year, like for example, you can see the top right here on the screen of the red box. That's teosinte. That's the ancestor of corn. It's a grass that grows in Central America. They found evidence of it being grown or harvested rather, and then eventually grown and domesticated along the Balsas River in Central America and in Mexico. And so they found examples of microfossils of this inside old grinding stones in caves of ancestors grinding and also popping this. So this little grass seed, which is the ancestor of corn, also pops too. And then later there would be a guy named George Beadle who would test this theory by hybridizing wild teosinte with domesticated corn, and you can see the offspring in that middle. So it's if it can cross-pollinate, that means it's related, meaning it's there's that much of a match in it that it can create offspring together. So it's really interesting to see that over time of what we can transform, and this is generations of work. Just the same with the example of wild mustard, for example. Wild mustard transformed into cauliflower, which means they started breeding sterile flowers, and then you get those big clumps right there for cauliflower. And then broccoli, which was bred for suppression of the flower development. So rather than encouraging flower development, it actually they actually tried to suppress it when selecting and saving these seeds over generations to attain broccoli. Same with cabbage, suppression of essentially the inner mode length. Kale, enlargement of the leaves, and then just another example right there with the I always forget how to say it, Kalribari. And so, anyways, it they bred them for certain conditions that they wanted to see, and that's what their ancestors wanted. And so, when you're doing this work, you're essentially plant breeding, and when you save seeds, you save for the things you want to see in your seed, whether that's say it's corn, it's you wanted bigger kernels, or say it matured faster and you want to save seed for that, or say there was a color that you liked, or there was a taste that you like, or there was a texture, or there was more successful growth in one on the drier year, or anything like that, any of those advantageous things that you're seeing in them, saving for those things that you want to those traits and attributes that you want to see in those plants over generation. And that's what our ancestors had to do. And it would be such a shame to see these seeds vanish off the face of the earth if there was no one growing them anymore because it literally took generations to do that work. And I'm going to go over next some types of seeds you'll see out there. So there's first one I put up here is what most people know is like heirloom seed that's been grown in a certain bioregion area for generations, usually at least several generations. And then there's also all people also refer to as landrace seed, which like the etymology of it is that essentially what people refer to as common people seed. So seats that have been like, or, attached to maybe a certain community, a certain group of people, smaller areas. Yeah. So that isn't widely available to people. I also refer to them as maybe as indigenous seed too. So that's typically what I'll call them, seeds that are at home and have been grown in the areas for long periods of time. So, heirloom seeds or landrace or whatever we want to call it, indigenous seeds, they're at home in the soils and moisture and climate they've been planted in continuously for generations. Um, Southwest varieties in particular, for example, are both resilient to drought and can withstand longer periods of without water. Can also withstand higher temperatures and can grow, yeah, just an overall more arid environment, like the seeds we see here in communities like mine or Hopi, Pueblo, or Zini Pueblo, any of the other communities here that live in a drier environment. And they're also naturally nutrient dense with nutrition. Meaning that if this, especially if the soil's been stewarded very well, and we've been growing with our old ancestral practices, usually means that the soil is healthier, which means the plants are also healthier. But also you get these different colors that are associated with different types of maybe corn, bean, squash, whatever. Each color is associated with different types of antioxidants. For example, with pinkish or bluish or purplish kind of pigments you see with corn or even berries or beans, whatever. Those have what are known as anthocyanins, which are another antioxidant. And there's also the ones that are associated with like reddish or orangish type of fruit or seed. Those are heavy in what we call beta carotenes. So those are kind of like anti-aging antioxidants too. So with help with the fighting free radicals and help with cellular regeneration, those types of things. So they make us look more and feel more youthful. And so they're going to be naturally more nutrient dense and flavorful and healthy for us. Most times, indigenous seed is also very hybridized, meaning that in a lot of communities like mine, they didn't have the space to really, say what something is true to type, which are something a lot of seed savers aim for. But communities like mine, you'll see very, like sometimes a patchwork of colors come up. But they also practice like good seed saving skills by selecting for the qualities that they wanted to keep. Maybe that was keeping the white corn white, and only selecting for ones that came up true white as opposed to selecting the ones that looked like they had been crossed at one point, or saving the ones that had been crossed and creating something new. So, it's something that happens like that. And varieties like these are quickly vanishing because they typically come from smaller communities, smaller groups, and thus a smaller handful of seeds that people are stewarding. And so we're seeing like a massive die off of biodiversity of these types of seeds because communities like mine, where they stop growing as much, then if there's no more farmers, no more farming anymore, then the seeds typically start to vanish too. And I always kind of bring this to attention to people, like, there's literally like, I don't know, countless numbers of corn, types of corn too, colors, textures, everything. And a lot of us think that, corn only comes in yellows. Or this little meme I have up there that says, you also colonize, you think corn only comes in yellow. You only think it comes in yellow dent number 5. That's the most commercially available seed out there. And then this is what biodiversity looks like for me. This is what we're stewarding here with our community. There's these two types of squash here that you see represented. There's the pinkish and the bluish, and also sometimes even a yellowish color, but they all come from the same seed. Those one pinkish and bluish ones and the yellowish ones, they all come from the same seed. It's amazing to see, honestly. The pink ones would surprise you. They come out a little more sweeter. The bluish ones come out a little more peppery. The yellow ones are really sweet. If you can find those, those are more rare. But we call those the Titi Shokotani or the North Side squash in my community. And there's also the mixed pumpkin. You can see pumpkins in there as well. And we call them Kaya Atanis, which means mixed pumpkin, mixed squash, because they come in so many colors. Sometimes they're pure light green, dark green, striped, yellow, orange. They can just come on so many different colors. There's also watermelon there, yellow meated, red meated watermelon that my community has been stewarding for a long time as well, and other communities surrounding. The other types of seed you'll see out there is organic seed, meaning it's been grown under organic conditions, and it's a seed that's sometimes just been doesn't necessarily mean it's like, for example, like totally free of like, amendments or things like that, but it's been grown in whatever the conditions that qualify, usually by kind of some state entity or local entity that the what the criteria is for growing organic. Usually it means non-pesticides, non-herbicides, things like that. And it's been grown under organic conditions, like meaning it can't have any like probably synthetic fertilizer kind of thing, only natural ones. And it's selected and grown under organic conditions, meaning that it's typically more expensive because it's more expensive to produce. And it's usually it has not been modified in some way. Like most people know genetically modified seed as GMOs, but a more accurate term would be more transgenic plants, meaning they're transferring the genes of not only other plants but other beings, other like bacteria, plants, animals, whatever, genes from them into insects into the seed and genes of another plant of a seed. So that means it doesn't have that and any of those kinds of alterations in them. Doesn't have transgenic genes in it. And it's also, expensive. Like I said, typically, if you ever bought carrot seed from Johnny's, for example, which sells organic seed, you know how expensive if just like a couple, like half a pound of seed is for them. It's pretty damn pricey. Um, so next section, I'll get into the life of plant, which is kind of the heart of seed saving. So the first things you need to know when you're handling working with plants is what's understanding the life cycle of it. Is it an annual or biannual? Is it going to take one season of growing to get the seed and the crop, or is it going to take two seasons? Corn, for example, one seasonal, it's an annual. Biannual is an example of that is like carrot seed. Carrot takes almost like basically 2 years worth of work to actually get the seed out of. Grow it one season, the carrot develops and everything develops, the root develops, and then you have to what's called stratification, meaning overwintering it. Then it has to go over the winter, and then it comes out again the next year, and finally it grows, and then it bolts, meaning it grows its flowers, its reproductive parts, and then eventually you get seed. But even that takes a while for the seed to develop and grow too. So then you still have to clean and process it. But anyways, so that's an example of a biannual, and a lot of root crops are typically biennials, meaning they have to go through that overwintering stratification process to produce their seed. So that's something really helpful to know, right? You can't expect to get carrot seed out of one season of growing. It's going to take, a couple of seasons to do that. But with corn you can. And then how does it reproduce? So, meaning like how does it have its children? Is it self-pollinating, which is easier to save seed for? Or is it wind-pollinated, meaning is it relying on the winds and the gusts to propel the pollen to move towards the female part of the plant and thus fertilize it? Or is it dependent on insects, moths, bees, anything else that is a pollinator to move the pollen around to fertilize the plant, thus getting the fruit eventually and seed. Or and number three, how far apart do I plant them to avoid cross-pollination? If you have self-pollinating, it's not too difficult to do that. But if you have wind pollinated, insect pollinated, those are called open pollinated varieties. So the wind can carry pollen up to 5 miles. The bees, insects have like radius sometimes of 20 miles, so they can carry pollen around. And so you need to know how far do I need to space them to avoid cross-pollinating if that's your intention. Or if you're to hybridize them, you probably want to know that too. How far do I need to space them? But so think about distance, timing, physical isolation or hand pollination, and then also the last thing, how many plants do I plant? The number of them, and that's what you call genetic biodiversity, which I'll get into in a bit too. So going
Hey,
into how,
sorry, really quickly,
yeah,
there's a question in the chat that is like directly related to that, and I'm sorry to interrupt,
no,
but
go ahead. That's great.
B, could you come off mute and could you ask your question here? If not, I can read it. Okay, I'm gonna read it. What are your thoughts on cross-pollinating different seeds of the same genus, i.e., two different types of squashes that are related in different types of maize, for instance? They also say it will completely change the plant and won't be true to type. Some people say to keep heirloom seeds true to type.
hmm Yeah, it just depends on your intention. If your intention is to breed a new type of plant, by crossing two different, like say you had two different Cucurbita maximus, which are like a type of like for example, you have a Hubbard squash, which is a Cucurbita maxima versus and plus a what else is it? I believe a butternut squash is also Cucurbita maxima. So if you wanted to, if your intention to get those two, you can do that. But then you also have to know that it's going to be a lengthy process to get a true, I guess, hybrid of both because that's why people warn against saving seed from hybrids because it won't always come out true. So the first year that you say you cross pollinate two species or two species this of the same species of a type of squash, for example, it won't always come out true to what you want it to be, which is should be like maybe the best of both worlds or something. You want it the same, the sweetness of the flesh and the color of the rind of another thing. So something like that. I use the example of even one of my friends is actually breeding a type of corn that's a cross between a this what do we call Havasupai corn and a sweet corn. And first year they cross pollinated them and they did a breeding program. And so first year they had some that were just a little bit of the same of both. They retained the color and stripings of the supai corn, but also it's also like wrinkly like a sweet corn too when you take the seed. But that's what you call F1 generation. So it's one generation that you've cross-pollinated, but it's going to take several generations to eventually see a uniform of what you want of both qualities. So if that's your intention, just know that's going to be probably years worth of work to do that. Another example of that is what people know as glass gem corn. Carl Barnes, who was a people he claimed what was the descent? Cherry, I think it was Cherokee descent. But he was a seed saver that was based out of Oklahoma, and he cross-pollinated several types of flint and popcorn together with different colors, and that's how you got what. And it took him years to do that, and it eventually they got what we know as glass gem corn, which is this beautiful, patchwork of brightly colored aluminum, almost this shiny gem looking kind of corn. So if that's your intention, whatever your intention is, you want to do a breeding program, that's good. If you want to create something different, that's up to you. But if you want to keep something that shoots type, it just depends on your intention. So I'll say that's nothing necessarily wrong or bad about that. I also probably want to think about more implications about like if the seed that someone gifted to you maybe and they ask you please keep this true to what it is, then I'd be like honoring that too. So there's a lot of things that come to that think about that too as well. So does that work for the answer? Okay, I'm assuming it does. If I'll just continue then. Hope that works, and if it doesn't we can kind of follow up on it too. So let's see, going into again, basically reproductive mechanisms within plants. So this is where you kind of put your botanist hat on a bit. So there's male and female parts in plants, right? Just the same as people. Maybe there's the part that fertilizes the female part of the plant, and then there's the female part of the plant creates the fruit and the seed. So the male part is known as the stamen altogether, and then the anthers, the filament is basically what holds up the anthers, and then there's also the anthers are the pieces that actually create the pollen and drop the pollen. So those right there are what the male producing parts of it, and pollen, is essentially, just to say, it's all science and it's all biology. Reproduction. It's basically like the sperm, it has all the DNA and the items that that needs for fertilizing and creating new life. And so that's what they look like. The anther is the pollen producing of the part of the plant. And then you also have the stigma. So, oh, I forgot to mention, this is an example of a perfect flower, meaning it has both male and female parts in the same flower. There's also plants that have totally different male and female flowers on the same plant. And sometimes there's even plants that have male and female plants. So the ones that have both the male and female on the same plant, and they can have perfect flowers in them or they don't have to, but those are called monoecious, meaning they have all of the reproductive flowers of male and female parts on the same plant. Then there's dioecious, means there's male and female plants. Sorry, I hope that's not confusing, but as that's essentially what you can run into out there. And then there's the female part of the plant, which is the pistil. Right here at the base of it, you can see that's the ovary. So plants have ovaries just like people, and you can even see the eggs in there that haven't been fertilized yet. And then you have the style, which connects to the stigma. That's the receptor of the pollen. So the pollen from the anthers has to fall on that stigma right there in order for it to be fertilized, in order for the fruit and then the seed to be reproduced. So you need that to happen, and that can either be wind pollinated, self pollinated, insect pollinated. So this is an example of a perfect flower that again that has both male and female parts in there, and that's the reproductive part. So I'll go over, I use corn, beans, and squash because they're perfect examples of corn being wind pollinated, beans being self-pollinated, and squash, which is insect pollinated. So I'm going to use those examples, and I have little videos in here to show you all just of how that works exactly. So the tassels, or the male part of the plant, are the parts. You can see the little pieces hanging off the tassels right there. Those are the anthers, the part of the plant, the male part of the plant that produces pollen. You can see the pollen flying there because it's wind pollinated. As soon as the wind hits it and it sways, it starts releasing pollen and it travels through the wind, moving through the air, and eventually it should fall onto each of these individual corn silk strands. And so if you ever open up an incomplete corn, you'll see that each one of these corn silks leads to one individual kernel. And so all the pollen has to fall and fall on and fertilize each one of these corn silk. And if you don't, then you get sometimes you get what's called like partially fertilized, and then sometimes you get areas that are not fertilized at all, which we call like naked ears of corn. So that means that pollen didn't fall on any one of these. You can see some kernels that are partially developed and some that aren't developed at all. That means it didn't get enough pollination. And if you're like a backyard gardener that's trying to grow corn, that's something really important to know because as soon as your corn starts pollinating, you'll probably want to hand pollinate it. Meaning you probably go in there in the morning. Pollen always produces best during the morning time. Usually once the sun hits it, in the morning time, it starts releasing pollen. And if you go in there early in the morning and catch it while the pollen's still there, you can either just kind of just push one plant over and just a little bit and just try to shake it a bit and try to drop all that pollen on all the corn silks around each other. Or you can like also like get a bowl or a bag and kind of dust the pollen off from your plants and then individually like fertilize and dust your corn silks too, so that way you get full ears rather than naked ears. I don't know if anybody out there who's done that before. You get excited and you open up that corn at the end of the season and there's no kernels developing on there, and it's because like it didn't get pollinated. So that's why with corn it's sometimes you do pretty much need like either hand pollinated or a large number of plants to make sure that there's enough pollen flying around that all the ears are going to get fertilized. And then there's beans, which are an example of perfect flowers. And so meaning they have both male and female parts in the same plant. And they don't need insects, they don't need the wind, they can do it all on their own without worrying about any of that either. So beans are an example of that. Most legumes are self-pollinating, or pretty much all legumes are self-pollinating. Nightshades are an example of that. So tomatoes are self-pollinating, for example. But once they pollinate themselves, and they get, then you get your beans and your fruit, and then you get these plant babies there, and the cycle of life continues again. Now you have insect pollinated like squash or even melons, another example of that. So you can see the bees, slowly gathering that pollen and flying around. And that's really interesting to note. There's certain species. There's even like so many different species of bees, native bees and whatever else, or even just the most domesticated, whatever honeybees, and what a lot of people grow. But these are like one of our bees that we know as like squash bees right there. So they specifically go after the pollen of squash too. Pretty neat. And they kind of live in the ground. They don't really have hives. So you can see them gathering pollen right there and shooing the other one away. And then they move on to the male part of the female flower. So you can let the bees do the work, or right here you can also hand pollinate using the anther from the male flower and just kind of rub it on the female flower. Or you can even use a paintbrush and collect the pollen that way and just kind of rub the paintbrush on the female part. So just a little recap. Another example like the melons. So the male melon flower, it has the pollen, the anther right there in the center that produces the pollen. Then there's the female part, which you can tell is a female because it has the bulb in the bottom of it. That's the ovary, the part that will produce the fruit and the seed eventually. So if you can get the pollen and transfer it there by using, getting the flower itself and rubbing it on the female flower, or getting a paintbrush and doing the same thing, or just letting bees and the pollinators do the work for you if you have enough of them around. So yeah, just note that that's what usually the bulb is what means it's a female flower. That's pretty good indication of the female flower. And then if you get do it right, thanks to your friends like the bees, you'll get a beautiful melon or a squash like that. Just another quick recap of the whole thing. So this is the pollen, the anther, the male producing part of the male flower that produces the pollen. You can see there's no bulb at the bottom of that. And a closer look at the anther right there. Yes, the filament that attaches to the anther that produces the pollen. And then you also have this right here. You can see the female flower, I should say. And then there's the ovary and the base of it right there. That will eventually turn into a fruit. And if it's pollinated, then the cycle of life again continues too. So you have those ones there. So you can see this one got pollinated pretty recently and the flower's drying up and now it's producing the bigger fruit. I'll take a pause right there if there's any questions about the like pollination or anything like that, or if anybody wants any more information on, yeah, kind of the reproductive parts of plants.
Beto, you had a couple questions. Would you like to come off mute and ask them here? If not, I can read your questions for you. Okay. Beto, I'm going to read your question for you. The first one up here at the top, do all biennial seeds need to be stratified? And the fact that it is a biennial mean the seed will need to go through stratification.
I'll say most times yes. So like most crops like all root vegetables primarily like say your beets, turnips, even radishes, all those carrots, they need to go through that kind of overwintering process to trigger their seed production because the first year they're basically growing their roots and getting strong roots there. And then the next year they kind of get the overwinter process, this which is their natural kind of reproductive process. And so then it gets triggered the next year after it's developed its root, then it shoots its flowers up pretty quickly after that. And then you start to get the pollinators, right? It took us, yeah, pretty much almost 2 years of to get our carrot seed. we're saving this heirloom purple carrot seed in Acoma right now, and so we learned that what a long process it is, all the way from planting all the way till harvesting and drying and collecting and processing the seed. So yeah, most biennials will need to go through that stratification process because yeah, that means that if they're biennial, usually means that they need to establish their roots first, and then for the first season, and then next season, then they are able to reproduce.
Thank you. We have another question from Colleen. Beto, I'll try to get back to some of your other questions. I just want to make sure we get all the voices in here. Colleen, do you want to come off mute to ask your question? If not, I can read it for you. Okay, I'm going to read it. Why do squash fruits dry up? Our squash plant bared many fruit to size show in your photos, but the flowers would dry up and then the fruit would not make it.
Hmm. Yeah, that typically means you might not have enough pollinators around, so that's where this hand pollination method would help out. It could also mean that I don't know if you were able to identify the female flowers, but yeah, they should have that bulb at the base of them. And I found that because of climate change and because of just higher temperatures, we were getting a lot more male flowers than anything else. We got very few female flowers the past couple of years. And that's because the plants also need kind of this homeostasis too. They need that good pocket zone of moisture and also climate to make sure they can have an environment favorable enough to trigger the female flower growth. And so sometimes that happens too. I noticed that when we have rainier years and it gets a little bit cooler during the summertime, then we get a ton of them. It's also could be maybe a nutrient deficiency too, because when you get the rain, you also get a big influx of nitrogen. Rainwater is the best water you can grow with. It's naturally has nitrogen in it that's been kind of basically dumped in from the atmosphere. It's kind of this lightning powered. So the lightning actually breaks up, there's abundance of nitrogen in the atmosphere. And so when the lightning strikes and there's rain, that lightning actually breaks up the bonds to make the nitrogen soluble. And so then you get natural nitrogen coming down in the form of rain. And that's why you see a lot of like probably an explosion of growth whenever you do get those rains. And then thus make it like a healthier plant and also creates conditions and climate cool enough to trigger more fruiting and production, things like that too. So yeah, it could be a few number of things. And so yeah, hopefully that answers your question. It could be again nutrients, it could be the climate, and it could be just maybe not enough pollinators around your area, which would help, but if you are seeing those female plants, female flowers, then you can just do the hand pollination method I kind of showed you there by either taking the anther off and then just rubbing it on the female plant or getting a paintbrush and rubbing some of the pollen off and then hand pollinating the female flower. Cool. Anything else?
Beto, did you want to follow up on your question?
Hey, can you guys hear me? Okay. I'm not sure if
You're a
you can.
little muffled.
Okay, yeah, my mic kind of stuck on this. So I'll try to speak up. No, maybe I should just type.
Uh, yeah, try your question. We'll see if we can hear you.
Okay. All right. Just to follow up on the stratification. Um, so I understand that the seed itself, like from the for the vegetable to produce seed, it's gonna take 2 years. 1 year in the fully in the ground, and then the next season it's gonna shoot up and make the flower and then the seed. Um, but that seed itself, I feel like if it drops, um, will it germinate automatically if like the conditions are correct at that moment? Or like at that point, if you're trying to save that carrot seed, um, would it have to go through? My understanding of stratification is that it has to go through that cold dormancy period of like 30 or 60, 90 days or whatever it is, depending on the plant. And so I'm just really trying to get a better understanding of like with that, like what determines that for certain. seeds in certain plants when it comes to whether it needs to go through a stratification period. But like that carrot seed itself, if I take that carrot seed in the fall or like whenever it finally comes to fruition, from that carrot that has been growing, and I take that seed and I plant that seed again that season without having gone through that cold dormancy period, that's I think it might germinate. And I'm not and correct me if I'm wrong. Like, does it have to go through that like that cold period again? The seed itself. I'm so
Uh,
sorry. I was like yelling because trying.
no, no, that's good. We can hear you great, and I think I got your question too. So thank you, Beto. Let's see. It, So say you like you said, if you save seed and you planted one season and you successfully stratified and then you went through then it gets its seed production and then it's the seed is ready again to grow again. So then you save that seed and try to grow it. Unless you're trying to save seed again, or you just want the carrot itself, you can it depends, right? But if you just want the carrot itself, yeah, it's gonna of course you can plant that and it's gonna sprout, it's gonna germinate. But if you're planning to save another generation of seed, then you need to go through that same process all over again the next year and say grow that carrot seed and then regenerate it and go through the stratification process again and then you get another generation of seed after that. Um, so yeah, it depends again what your kind of intention is. But yeah, if you're just wanting the fruit, then you can, just that first generation of carrot seed you saved, plant in the ground, and you can harvest that in this one season. But if you're gonna save seed from a second generation, then you're gonna have to go through that same process all over again.
No, I think um I think we're not under. I'm like it's hard to communicate this, but so I'm just gonna try to I'm not gonna try anymore. But to me, I'm not trying to save. I'm not communicating this well. So I'm gonna stop. But we'll try again some other time.
Okay.
Okay.
Yeah, yeah. If you wanna like kind of rephrase it, maybe maybe at the end of it we can try that again. Sorry, maybe I'm not quite understanding myself. Yeah, but thank you for the question, though. Yeah,
Yeah,
don't want to discourage you
stratification.
from asking again either.
Yeah, no, we'll keep talking. I just feel like I need to thank you.
Okay. All right. Okay. If that's okay, we can maybe move on. Then I'll pause for another time for any more questions again, once we get through this next piece. So we just talked about the reproductive parts of the plants and reproductive reproduction methods. And so now we can go into just yeah, just time and space, really. And I have this little background here of when I grew in 2020 of all these different varieties I wanted to grow because we were all freaking out. So is the food system secure? If not, I'm gonna grow as much as I can. So I literally grew everything I could and tried to create enough time and space to be able to save seed that would be true to type because I wasn't intending on breeding or cross-pollinating anything. So to make sure that I was spacing things out enough adequately between if I had two types of the same species of a plant. So I also had to make sure that I was timing things correctly too, to make sure that I was going to get seed from it. So all those things had to happen. Um, so the next part I'm going to go over is like this is gives you a bit of a scale, a little spectrum of um, the mating systems and also isolation requirements. I got this through Seed Savers Alliance. This is one of their slides because it just did a great job of explaining that. So on the one end of the spectrum, you have like self-pollinating plants, and meaning that it needs because it's self-pollinating, doesn't need the insects, it doesn't need the wind, so it just needs it can pollinate itself. So with that, you have let's see, like for example, legumes, beans, peas, things like that, and lettuce, tomatoes. So those typically are self-pollinating, and they'll only need very minimal distance between maybe two different types of the same species. So say you had, I don't know, what is the term? Like a ponderosa and a beefsteak tomato, which are pretty similar, but you wanted to save seed from them. You don't need to necessarily isolate them too much because they're self-pollinating. Most times they'll pollinate themselves before they even have a chance of anything else getting to them. but there's still the chance of insects carrying pollen around, and so you still have to think about that too. So it's which is why they offer like some distance. So um, yeah, but so there's the distance and the number of plants. So that's the number of plants you want for genetic diversity, I guess, is what you say. So meaning that you don't want like a what we call inbreeding depression. So you got to save a certain amount of seed from a number of plants. Um, so this should just give you an idea. And then in the middle of that spectrum, you have like squash, which we bees can travel like pretty long distances. And so and also you need a good number of squash to make sure you have good genetic diversity of it too, to make sure you're not going to have inbreeding depressions. And I'll talk a little bit more about that just so y'all can understand that concept a bit more, but just prefacing it right now. And then you have something way on the way other big spectrum, which is corn. So corn, for example, is one of the hardest things to save seed from, to be honest. Everybody wants to start off with corn because it's attractive. The people want to grow corn and save seed from it. But if I were to recommend to a beginner of learning plants, I might start off. Why don't you try some beans first, and get your hand in that, and then you can kind of work your way up to if you want to kind of learn a little bit more about how all of this seed saving world. But corn, for example, corn pollen can fly up to 5 miles. So, if you have a neighbor like within 5 miles, there's always a chance that the pollen could fly your way. And then you also want at minimum 200 individual plants to save seed from what corn. Corn is naturally prone to those inbreeding depressions that I talk about. So, meaning if you save seed from a small number of corn over and over again, you're going to cause that go into inbreeding depression, meaning it's kind of like, you know, very close relatives, meaning with close relatives, and then you get a bottleneck gene depression. So that will mean eventually you could also run into, say, lower yields. It could also be more prone to disease. There's just a whole number of things that can happen. So that's part of being a good seed saver, making sure you know what's the number of plants to save seed from in a given season. I'll start off with beans. And so the other thing to know, again, I mentioned the genus and species of plants. That's where you put on your botanist hat onto, and you start kind of getting familiarized with those. So I'm going to kind of give you all a brief overview of that. Of when it comes to beans, there's about four different types I cover. So the first one, and beans again, are self-pollinating. Um, the common bean, which is known as Phaseolus vulgaris. Phaseolus is the genus, and vulgaris is the species. So all the beans I'll be going over will be in the Phaseolus genus. So um, common beans or Phaseolus vulgaris are species like pinto. Most people knows the pinto, right? But they also are cranberry beans, the Anasazi, or the Jacob's cattle. Some other examples that we grow which are in this picture, are the Hopi purple string beans and the Hopi yellow. One year I did, although they are self-pollinating, I did plant them pretty close to each other, like within the same area. And I did notice that the bees probably had transferred the pollen over to the other. So I was seeing like a hybrid of both of this yellow and purple bean that we grew. So those are things just to keep in mind, when you're spacing things out in your garden, in your field. So because all Phaseolus vulgaris will cross with other Phaseolus vulgaris, but they have to be within that same species, the vulgaris, to cross. If you have a Phaseolus vulgaris, and the next one we're talking about, which is the lima bean, Phaseolus lunatus, they will not. So remember, same species will always cross with each other, but because one's a lunatus and the other is a vulgaris, those two aren't. It's not possible for them to cross with each other because they're not closely related enough to cross. So these beans are typically broad and flat. They're slower growing for sure. I always have a lot of green beans at the end of the season that don't make it because they're slower growing. The flowers are typically found in clusters. I wish I had a picture of that. I actually need to put that in my presentation. But they're usually found with these clusters of flowers. They're really pretty, and they can be either eaten mature or shelled, like dry beans. But this is a Hopi red right there, Hopi red lima bean. So that's another example of a bean. So this is the second type. So Phaseolus vulgaris, and Phaseolus lentis, lima bean, and now there's the runner bean, which is a Phaseolus concaneus. Runner beans, if you ever encounter runner beans, they're huge. The seeds are giant. They're pretty meaty, big looking beans. And the way I usually tell them is by like they're typically what are referred to as pole beans, meaning they send out long vines. They kind of need a trellis a lot of times. And most runner beans are named after their colorful flowers. For example, right here, this purple bean right here, it's named after its flower, which is this beautiful scarlet colored flower that grows too. And so it's called a scarlet runner bean, which is named after its flower. But that's a Phaseolus concaneus. Then there's but a concaneus will not cross with a lunatus or vulgaris. Last one I'll go over as far as beans are the tepary bean. So this is a Phaseolus acifoliatus, meaning it's a pointed leaf plant. So it's named after its pointed leaf of the plant. And then these are those of you not familiar with tepary beans. They're native mostly to the southwest, especially Sonora, the Sonoran Desert. The ancestors of the people that live here, like the Hohokam, which are claimed as ancestors usually of, for example, the Tono O'odham or O'odham peoples. They cultivated these and were more than likely the ones that domesticated these beans. These beans grow in the mountains of the Sonoran Desert. And those folks brought those beans down into their farms and fields and started domesticating and breeding them. Then you get this beautiful rainbow color of tepary beans right here, for example. So really pretty. You see the black, the chocolate ones, the brown ones, the yellow ones, the speckled ones, the white ones. And these are all like Tano O'odham beans. And these are some of the most drought tolerant beans in the world. They're also some of the most nutrient dense beans in the world. They have more protein than any other bean out there by a long shot. Just for example, if you go to Ramona Farms online and you see all the tepary beans they sell on their website, and they did the nutritional kind of content on their packaging. They say about a quarter cup of, I think it's half a cup of tepary beans is the amount as about runs around, I think it's around 23 or 28 grams of protein for just a half a cup of beans. So pretty nutrient dense and pretty protein dense too. So anyways, the teparies they're really arid adapted. They're used to growing in those really hot arid environments, and they actually love the the drought conditions to grow. And so, but that's another bean right there, the tepary bean. So for example, right here, if I wanted to make sure I'm saving seed true to type, like for here, I could have planted two common bean sticks next to each other, but maybe that's not the best. What I could have done alternatively is probably, put a runner bean and then a common bean next to it to get a lima bean to give it more space and put two common beans that I know it can cross, kind of a distant, farther distance away from each other. That's if you're saving for multiple different types of species of the same species. I'll go over briefly this one too, the squash. So there's just so many different types of squash. There's the cucurbita pepo, which are mostly like typically pumpkins. They're also known zucchini are examples of pepos, spaghetti, even some types of gourds too. But most gourds that most people know, they're a whole different family. They're a whole different genus. But that's one example of a cucurbita pepo. And these, of course, are insect pollinated, so you got to space them out pretty far. Um, and then there's the cucurbita moschata. Example of that is the butternut squash. And then there's the cucurbita maxima, which is another example are Hubbard's, mint pumpkins, and like the Turk's turban. So quite a few different types. And these are example right there of the seeds in the plant right there with the Acoma north side squash that we grow. And there's the cucurbita argiosperma, um, which are like mostly people know as a cushaw. And there's so many different types of cushaw squash. There's like a Navajo cushaw in the southwest. There's a O'odham cushaw. There's a Pueblo cushaw, and some cushaw that have these silver edged seeds too. They're really pretty. They actually almost sparkle a little bit, have this metallic color to them. And they were bred specifically for those seeds too. So some cultures, it's not just the fruit they're breeding them for, but the seeds too. So anyhow, those are examples, but know that again, they have to be the same species to cross. So I know I can plant a maxima next to argiosperma, a cushaw, and a hubbard, and they will not cross with each other, so it's going to be safe. I can save seed from multiple types of squash. We can skip this part just because it's a little getting a little late on time. So I'll use the last example I'll use is corn. And those of you that know, there's different types of corn. But they're all within the same genus and species. So every single one of these will cross with the other. So there's popcorn. And what differentiates all of these corn is what we can call the endosperm. So the endosperm is basically the starchy content, usually the starchy content of the seed. And there's the germ itself, which is the part that actually sprouts and grows, the stem, and that's why they call it germ and germination. Germinate is this is the part that actually sprouts and grows. And then what the germ, once it germinates and sprouts, it lives off that endosperm, which is basically full of carbohydrates, the starches in there. And then that's what kind of sustains the plant for a while in its first inception. And that's what we live off too when we consume it too. It's the starchy endosperm and the germ too. So what we consume, what powers us too when we eat these, just the same way it powers the plant and the new sprout, the new germination. So there's different types of endosperm. There's the hard endosperm, which popcorn and flint corn have, and then which they usually appear glassy and look in color because of the hard endosperm that they have in them. And there's also flour, which is soft, starchy endosperm, which is going to be easy to grind and used for flours. And then there's the dent, which has a mixture of basically like the flint and the dent. See the hard endosperm on the bottom of it by the germ, and then there's the soft endosperm in the center, which gives it that dent because it kind of sinks in because of the soft nature of the floury endosperm. Then there's the sweet, which looks totally different from every other ones. If anybody's ever seen sweet corn seed, it just shrivels up. It looks like a raisin, and that's because it has sugary endosperm in it. And there's also another one called pod corn, which has like its own individual kernel wrapped around each husk, which is kind of a more ancient corn, kind of retaining some of those old qualities that, for example, of Teosinte, the ancestor. So just know that, but know that all corn, whether it's sweet or flour or flint, whatever, they will cross with each other. Just like I mentioned, that friend that's crossbreeding a sweet corn and a flour corn together to create a uniform one. Last part I'll mention here is just the genetic diversity. So I mentioned inbreeding depressions and bottleneck depressions. So you need to know of how much, and it's really easy. I'll give some great recommendations. There's some great books out there that are give you a wealth of information on seed saving. This is kind of just the introduction, so I'm giving you all the basics of it. So do your own research and like look up what each plant you're growing and saving seed for. What are how the minimum amount of like at least minimum amount of plants you want to save seed from to maintain the genetic diversity. So if you're maintaining genetic diversity, you're creating basically a vigor in the plant. You're making it healthy and it's going to grow even better sometimes. So sometimes even what I'll do, I'll actually take, we grow white corn here, which is grown right there in the picture. And I'll introduce one white corn species with another white corn species. So I'll grow an Acoma white corn with another Pueblo blue corn, or maybe I'll get seed from. We also do this within our community too, in Acoma. During the winter solstice, we actually share seed and we mix the seed together from all the different community. So we have white corn from one family and white corn from my family or other families, and I take some of that white corn from that seed that we share, mix it all together, and then what I'm getting is a boost of genetics in there. And that's what you call hybrid vigor, meaning it's just become more virile and vigorous because of the new basically shot of genetics that got input into it. And that's a amazing practice that a lot of our communities have always practiced to make sure they don't have those inbreeding or bottleneck depressions in their corn, for example. So the corn is again is really prone to these bottleneck depressions. So I'll give you an example of what I've seen, what some seed banks have done. I won't name which ones, but some were not doing great seed saving practices. When they collected the original samples from a community, they only collected a few ears. And then they started saving seed from that and saving from small amounts of seed every single year. And eventually, what happened to this particular seed, which was, I'll just use an example, it was a Hopi pink corn. And this particular seed bank actually caused that inbreeding depression because of the small population that it originally collected from, but also the small number of seeds that it was selecting from too, plants. And then what happened was it started being prone and rife with the disease called Fusarium, which is a pretty common corn fungus, but it's terrible because it actually the fungus embeds itself in this within the seed and it lives there. So every time you plant it, it actually replicates itself through that seed too. And it's also hard to get rid of because it also stays in the soil as well. And with the seed bank, they actually had to destroy literally a whole crop of that Hopi pink corn and not grow it anymore because it was too rife with that Fusarium fungus. So that's just an example of what can happen if you don't maintain good genetic diversity within your plants and your seeds. So the minimum for corn they say is at least 100 plants if you can, and if you don't have the space like a lot of us don't, then that's when you like you work together with your neighbor or you maybe bring if it's the same type of corn, you get seed from another neighbor of the same type of corn and then you put that in your seed. Oftentimes they'll get asked by other seed savers, do you mind if I put in some of your corn into my white corn, your white corn into my white corn or blue, whatever it is. And I'll say, yeah, that's fine. They just wanted to give the plant hybrid vigor and give it a boost of genetics that, it can share. So you can do that, but minimum optimum would be 200 and 500. That's what we aim for with my program in Acoma, our program in Acoma. We try to shoot for at least 500 plants to put in the ground. And so with that, we always have loss of with animals or whatever else, human error, but at least I'm doing my best to make sure I'm having that genetic diversity in there. And then beans, minimum 20 to 30 plants. And then optimum 50 to 100 plants would be even great. You're just giving it more chance for that vigor and that the health of that genetic health of that plant. Squash, 100, I mean, 10 to 20 plants minimum. Optimum would be 25 to 50 plants. And that one's hard one for us because we get the squash bug in our area, which is just so rife, and it's been hard for us to make sure that we're stewarding our squash right, to be honest. So just just a recap of what we learned. Before we get to this, I'll pause for questions again. I know it's a lot of things to cover. Again, you're kind of putting on your botanist hat with this kind of stuff by getting to know the genus and species of your plants, just to know what will cross with another plant and what won't.
Awesome. Thank you, Aaron. There was one person who we skipped maybe like 30 minutes ago, Stephanie Rocio. I saw you had a question. Did you want to either ask or I can also read your question?
No, I can hop on here. So I sorry. I was caught off guard because I was replying to somebody. So I work at the Forest County Potawatomi Farm in northern Wisconsin. And if you haven't heard of the Potawatomi Gathering, it's, a huge deal. So next year, Forest County Potawatomi is hosting, and I always grow sweet corn in one of our hoop houses. And we also have a large field that we grow field corn in for a corn maze because we do our fall fun at the farm thing in October. Well, now, because we do have 100% Potawatomi corn, pole beans, and watermelon seeds, we have to do a excuse me, it's a food sovereignty summit, I think is what it is, for this gathering, and I think they want me to grow these Potawatomi seeds. Well, these six hoop houses that I grow in are very near this field corn field. So now I have sweet corn in a hoop house. I have to
Mm.
have the Potawatomi corn, beans, and watermelon in one, and then I have this field corn. So I'm trying to figure out what do I have to look out for? Like what, um, I don't want cross-pollination. I don't want to affect
Mhm.
the taste of anything. We do have sides on these hoop houses that we can crank up and down, but there's just a lot of pressure for like possibly 5,000 people. that I
Hmm.
have to grow this for. So I just, what should I keep in mind as far as, not cross-pollinating, not affecting flavor of anything,
Hmm.
was pretty much my question.
No, that's a great question. It's really cool to hear about your work too. I've actually heard a lot about a lot of great Potawatomi seed savers, so it's really neat to hear about y'all doing that. Um, let's see. So, the biggest thing I'd tell you is just like space. And if you can even offset the time too, that's going to be another advantage you can have to make sure there isn't cross-pollinating because they are wind pollinated, right? And I mentioned that bees and wind can also carry the pollen easily. So what we've done in the past is stagger them, and if you have a long enough growing season to do that, they can do that. But like later, I'll plant in what we'll plant sometimes if we have the time and the water to be able to do it. We'll plant one type of plant, one type of corn, on one end of the field of that we're growing. Like I was growing a ton of autumn 60-day corn, and I really wanted to grow that. So I told him like, okay, this is going to mature faster than our 120-day corn. So I think I can save right here. So what I would do is, but I'll just to give it more time and distance between possible pollination times between both. I planted the 60-day corn first in April, knowing that it's going to mature a lot faster and give even more space between that time when our Acoma white corn is going to pollinate at the same time, or not going to pollinate at the same time. So I've done that too. Like some people are doing it with the moons too. So I did it one lunar planting in April, then another lunar planting in May. And then I also spaced them out as much as I could. It's hard, I know, if you're growing with smaller areas too. And then that hoop house will be a good natural barrier too, so that's good to hear. Another thing you can do additionally, what I've done in the past is even like make a wall of sunflowers, for example, just because they grow so tall and big. I've even grown like sunflowers around the borders of my corn just to make sure it's okay. Well, at least this will be a little natural barrier there too. So those are just some recommendations you can do to if you want to try and make sure that if you have your heart set on growing two types of corn in your area, then yeah, just to like create as much space, barriers, and space of time between the two is what I'd recommend the most.
I appreciate that because that's pretty much what I had planned.
Awesome. You're on the
I
right
had,
track then.
yeah, I had the different dates planned out, and then I thought, because so normally on the farm we have bees, but given in our area we have a shorter growing season for one, but it's also very expensive for us to purchase bees every year, for
Mhm.
our honey. It's, just doesn't pan out. So I am planning on taking our Taganas, our preschool kids, in spring. I want to bring them for a field trip out to the farm to create insect houses. So, for pollinators and whatnot for the year. And I want to house them in pollinator gardens, not next to, but near, not only the hoop houses, but also our orchard. Have a couple of them so we can, still attract our pollinators, with that same concept of we'll have spacing and timing of planting of the different corns. We will have our pollinators for what we need. Um, and yeah, everything else in between. So thank you. I appreciate that.
Awesome. Yeah, good luck with everything. And the other thing I'll mention last is too, also when you're harvesting, there's always the chance, of course, with the bees and the wind, there's just always that chance of a bit of cross-pollinating. Then just also selecting for the seed that you want to keep true to type. So if there's seed that ears that present full true to type of what you intended to, then you can always make sure you save from that and try not to save from any that might have just gone a little, maybe bit of hybridization going on there too, right? So selecting for the traits that you want as well is another thing. Cool. All right, well, thank you for the question. That was great. Anything else before we move on to the next section? Okay. Well, this is a bit of a quiz time, so you can quiz yourself. If you want to put your answers in the chat too, you can. But just to make sure we observed the knowledge here as much as possible, like with my facilitation, I'm all constantly just like going over it again. So I work with young people a lot, and my facilitator once told me, "All right, whenever you're teaching something new, tell them what you're gonna tell them, tell them what you told them, or tell them what you're gonna tell them, and then last, tell them what you told them again." So I'm just trying to reinforce this as much as possible. So, first question I'll ask y'all. Will a Cucurbita maxima, so Cucurbita being the genus and maxima being the species, cross-pollinate with a Cucurbita argiosperma? I'll give some maybe a couple seconds there. If anybody wants to kind of guess and put in the chat, you can. If not, it's fine. Just guess on your own and say it to yourself. Test your knowledge. What she absorbed. Okay, so I think it's not good enough time. No, because they do not share the same species. So remember, they do have to share the same species to they cross pollinate. So a maxima and an argiosperma squash will not cross pollinate. Only a maxima and a maxima will cross, and same with the argiosperma. All right, next question. Will a Phaseolus vulgaris cross with another Phaseolus vulgaris? Kind of just gave you all the answer, I think, already, but yeah. Answer is yes, because they share the same species. So yeah. Sorry, these questions might be a little easy. I don't know. I'm always adjusting my presentations and facilitation skills too. This one may be a bit of a loop right there too, because I don't mention the genus or species. But will a popcorn cross with a flint corn? All right. And the answer is yes, because all corn will cross with another corn because they were all Zea mays. Zea being the genus and mace being the species. So yeah, all corn will cross with any other corn you have out there, whether it's a flint, flower, dent, all of them will cross with each other because they're that closely related to each other. Awesome. All right, we're winding up now. We're at the home stretch. So, harvesting time. So, when do we want to harvest? Harvest at for seed at maturity. Can't tell you how many times I have to teach young people as mentoring. Don't, if you want to save seed from corn, harvest it when it's mature and brown. That means the pod has dried, the husk has dried, and the seed has had time to develop and dry and eventually cure. If you ever worked with corn before, you know it has this stage where it's pollinating, and eventually you get the fruiting and you get the ears on there. And then if you look under it, you'll notice that it'll go through kernel development stage, which is the milky stage. So then you can press upon the kernels and if it bursts, then it's in its milky stage, which is great for if you want to roast corn or or bake corn, whatever it is, or boil it. You can eat it that way if you want the green corn. But if you're going to save seed from it, you have to let it dry out. You have to let it mature. And so many people I know have tried saving seed from green corn. And I was like, sorry, it didn't make it to its mature stage. It didn't have time. Your kids didn't have time to develop yet, and you kind of took them off early. So only once that the kernels harden and the husk dries, then it's time. Same with beans. The bean pods will dry up. Sunflowers, another one right there. The whole plant will dry up, and then with chili, it's another thing, the different thing a bit. With chili, for example, with peppers, we have a lot of peppers down here. Once it starts turning red, then you can harvest it. A lot of people don't know, especially if you're outside the Southwest, that red chili and green chili are the same thing. Green chili is just the fresh chili, and then red is the mature peppers that are ready that the seed needs to go. And even when you harvest the chili, the red chili, you still need to let it dry and cure. So you can harvest red chilies and save seed from that. You can't save it from green chili. So once the chili starts maturing and turning red, then you can. What our communities do is typically form ristras. They make this braid of peppers that are red, and eventually they'll dry and shrivel up. Then you can save the seed from that once the seed is cured and dried. And then squash, a trick for that is typically it'll be the last thing you harvest. Trick that we use, the older folks in Acoma use, is that they'll get their fingernail and press it on the rind. If their fingernail breaks the rind, then it's not ready, especially if it's like a winter squash. If it's summer squash zucchini, you can harvest it whenever you want to. But if you're saving seed from it, even summer squash, you want to make sure that, yeah, the rind is hard and that it's developed. And so if you press it on your thumbnail within the rind of the squash and it doesn't break, that means it's pretty much ready. If it breaks, then it usually a little more time. Also, the vine will start drying out, and the tendrils, the little vines, will start drying off around the squash too. So that's another indicator for that. So just always knowing that for here. what we do with our corn is braid it and hang it up to dry and let it cure. And then once it finally cures and totally dries, because even once you harvest the corn on the stalk, and it's even though the husk is dry, you still need to let it cure because the seed is always still a little bit wet. It has this like glossy looking look to it when you harvest it. Once the color starts dulling and it looks like the kernel is really hard and you can't like rub off the skin, then you know for sure it's ready and it's dry and it's ready to put away for seed. Processing. So processing often involves threshing, which is basically like roughing up the plant to release the seed. You also sometimes have to screen it and then also winnow it. So you're separating the seed from the what's called the chaff or the plant matter. Also, been doing that. You're separating it from the dirt, the debris, and potentially maybe insects that might impact your dry seed while it's in storage. So here's a little video of that. This is our farm core staff right here. They're doing threshing it by doing a stomp over the what's called amaranth. It's a grain that grows on these bright orange flowers. And so you can see that by stomping on it, they got to release it. And then they're also threshing it by hand by rubbing and rubbing the plant and kind of helping release the seed. Then we screen it to try take out all of the bigger organic matter, the bigger parts of the plant, and screening it so we can get the grain. And it still requires more processing, which is winnowing, which is using the wind or fan to separate the seed from the chaff or the plant matter or the debris. You can see right there in slow motion, Sam, our farm technician, doing that right there. And eventually, after doing it a few times, then we were able to separate most of the organic matter from the grain or the seed. So there's an example right there. And like so you can use a box fan, you can use the wind if it's the right amount of wind too. It can be kind of scary when you're doing it. And the wind can be unpredictable. Fan is a little bit more predictable too. There's also mechanical threshers and winnowers. Former organization I work for, they used to actually give those out as seed equipment. They call them the winnow wizard. There's also these things called clippers. So there's machines out there that will process it to you, unless you want to go low tech and just use a box fan and a couple tubs and let it separate that way. And it takes a few times, but it's a little more tedious, but you can do it too. We do it low tech too. Um, I'll mention wet seed processing as well. So some fruits might require fermentation. Tomatoes are a huge example of that, and the main example of that, to be honest. So say you get the ripe tomatoes, what you're gonna do is if you open up tomatoes, you notice that there's this gelatinous gel or just gel around the seed itself. So in order to get the seed and save the seed, you have to actually ferment that anti-sprouting gel around it. That gel is a natural evolutionary advantage that it had to make sure that the seed doesn't germinate inside the wet fruit of the tomato. So it requires the seed to be broken down, the gel to be broken down through fermentation. Other examples of that, like tomatillos don't necessarily need to go through that, whatever, but most of them just need to be extracted. So what we do right here with the tomatoes is, push out the seed and ferment it for at least 3 days. You'll notice it'll start, it's kind of smelly, and even if you put it in a bottle, it'll start kind of probably getting foamy because the bacteria and microorganisms are starting to consume that gel sac around it. And once it's done its job, it's usually going to be a little stinky. Then you can strain it by water winnow, basically put it in a sieve and wash all that gel layer that's been broken down, which is probably pretty stinky. And then winnowing it and then putting it on the platter to dry. Roughly about maybe 1 to 2 weeks would be good to thoroughly dry. And just making sure that's another tip too, making sure your seeds dry adequately. There shouldn't be any real detectable moisture and it should be dry to the touch for all seed that you're saving before you put it away in storage. The very last part I'll go over is storing seeds. If you remember anything from this around storing seeds, remember this: cool, dry, and dark. That's what you want for all your seeds. You want it to be dry for one. I mean, your seeds should be dry. You don't want any wet conditions around your seed. Keep it away from any wet conditions, any humidity, any moisture. And also, you can do that by putting in some kind of container. You can also make sure that it's cool. The cooler it is, the more longevity you have of your seed. The hotter it is, the more your seed will probably degrade over time, meaning it won't germinate and won't grow. And then dark. So taking away from heat sources and light is a good practice too. So like our example of our seed pots right here, it's usually maintains the temperature because of the clay vessel, and also it's dry inside because we seal them, and it's dark naturally. There's no light getting into the things. So these are kind of like some of the optimal ways to save seed that our ancestors just figured out. And so yeah, just remember that cool, dry, dark place. The cooler, the drier, and the darker, or at least the cooler and the darker, the more longevity your seeds are going to have. In the short term time, you can save them. What I recommend is using gas permeable containers, meaning don't use plastic. Um, Paper bags are good. I love paper bags, and it's great because you can label them or write on them. I usually like to make sure our folks label everything, what when they were harvested, when they started drying it, what species, what variety, whatever it is, that they're growing. That's been there to make sure we're not mislabeling anything. So we always label it all with the name, the year, and the time we started drying it, to make sure we know how long it's been sitting there, and with the date. So it's good for short-term storage and labeling, and it's good for when you're not totally sure if the moisture content is dry enough. You can always put it in a brown paper bag, and it'll just naturally kind of let off the moisture after a while too. It's not good for long-term storage because it makes your seed susceptible to pests, insects, or whatever else, mice, whatever. And just know that moisture has the greatest impact on seed viability. So storing seeds above 90-degree temperatures, Fahrenheit temperatures, and a place that's 60% humidity or greater equals rapid seed viability decline, meaning your seed's not going to germinate as good. So, or germinate at all potentially. So, cool, dry, dark place. Just remember that. And the second part to that, long-term storage though, sealed storage is a must. I don't recommend plastic containers because we've had rodents eat their way to plastic containers and we lost a whole lot of seed that way. So the most accessible thing we found is just glass jars. Mason jars is what we use a lot, since we don't have access to a lot of traditional clay jars. It takes a lot of work and effort to do that, but for the amount of seed we have. But it keeps the moisture content level. It's yeah. And then recommend temperature. If you want to, you can also refrigerate them. You can, but recommend is between 35 and 38 degrees Fahrenheit. And then if you, the more, you can also put them in a colder storage for really long term. And that will increase the viability for up to 20 years. For example, if you put it 0 degrees Fahrenheit for 20 years or longer, it will actually increase the viability of the seed. But if you remove it from the freezer, just make sure you let it come to room temperature before you open up the jar. Too, they can a lot of um, moisture can get in there that way through like when you bring it out, um, the condensation and things like that. And then if you also are noticing you're seeing insect infestation in your seed, good practice is to freeze it. So put it in the freezer for a few days, and that will eliminate any pests you might have had in there. But you might want to label it and say like, all right, this was infested at one point, and we might need to use the seed sooner. And maybe sift out what a bad seed too, or a pest that might be still dead in there. So yeah, I'll end it there for now. I know we've been going a long time, so I'll answer any questions. But this is my contact information. If anybody wants to screenshot, and there's my email. And also, if you have any further questions, feel free to reach out. And I also post a lot of like educational content on my Instagram. So if you want to do that, there's a lot of like short, like just like 60-second videos that talk about a lot of this stuff that I just went over. And also, I'm gonna follow up with a Val here to send out. There's a little zine that we created for seed saving. I meant to give it to them beforehand, but I'll send that out too. It has all of the information that I went over with the genus and species of the plants too. So, and yeah, And I mostly focus on corn beef squash with our program. So it uses those as an example again too. So I'll say tahopa. Thank you everybody for listening and giving me your time and your ears. And I hope this was informative enough. This is just the intro. There's a lot to know about seed saving and a lot to pack in there. So I did my best to make sure it's try to be as digestible as possible. I know it's still a lot of information, but it's through trial and error that we learn and through our own experiences that we learn too. So I've made constant mistakes and I always try to learn from this best I can. So we're not always going to get everything perfect, but we try our best. And so yeah, I really appreciate you all for again, the time here today. Any questions that we want to follow up before we end our time?
Yeah, I do. I have a
Oh,
question. If
okay, great.
you mentioned storing in brown paper bags or
Mhm.
in kind of a pulp situation, can those seeds, once you put them in package, with those, like coin packages, can those be stored in plastic or should they be stored in glass?
I would just say for short term, you can do that. If you're just like maybe sharing seed and want to give out seed, we use the little coin pouches too for sharing seed sometime. And we use brown paper bags just if we're not sure if they're dry enough to put in long-term storage yet, sealed storage. But just in the short term, those are okay. But long term, you do want to make sure that's going to be a hard container, like a glass mason jar. If you have access to the like seed pots like we do, that's what we use. But in the long term, you want to have a sealed container. And I really don't recommend plastic containers because we've literally had rodents eat their way through what we thought was a really hard, thick plastic container, but they chewed their way through it and got a lot of our seed. So you just want to keep your seed safe and also make sure that the moisture content is good. Like say you have like, I don't know, for God forbid, like something flooding or in your area or your storage or rain got in there, at least you're gonna have a sealed container like a mason jar to make sure that the water or whatever didn't get to it, that it's gonna be, well preserved until you're ready to regenerate and grow the seed again. So short term, yeah, like paper containers, like the coin pouches or brown paper bags are good, especially if you're unsure of the moisture content in there, if it's not dry enough. If you don't know, because I've done that before. I put away seed where I thought it was dry, and then I get with a moldy jar later on. So that can happen too. But yeah, long term, I really recommend a hardy storage container. There's even some that are like metal containers that have a seal around them too, if you have the funds for that too. So, but what I would like to do too is compose a list of seed saving items. So I'm gonna make a Google Doc that maybe Val can send up in or the folks here, the hosts can send out in a follow-up email. That's really wanted to get to do today, but just didn't have the time.
And one more thing, once
Mhm.
you're ready to plant your seeds, do you recommend soaking them before trying as means before germinating them?
Yeah, lots of people do that. There's a lot of cultures and communities that do that here today. Even sometimes my family would do that. And what it does is it's you just gotta make sure that you're ready to plant soon, because oftentimes that's happened where they soak the seed to give them kind of like a head start, which is okay too. Um, and they ended up having to delay planting, yet the seed was already germinating, and then eventually it kind of like started fermenting too because it was too soaking too long. But just making sure you're timing it right with your planting too, and you're gonna have and be ready, have it ready to plant. Like soaking it for maybe like a day or two would be out. This sounds is fine. If you want to give them a little bit of a head start, some communities even like use example is actually put the seed in their mouth and wet it with their saliva and put it in the ground. So if it doesn't take much, especially like for corn, for example, like corn, like you can literally germinate with your spit. But yeah, if you want to do that to give it a bit of a head start, that's fine too. I personally don't do that very much, just because it seems sometimes there's a little more trouble because I end up using more seed or having excess of seed that I I can't use, and we've already planted our areas. So, and then also don't want to like, uh, for me, it's sometimes kind of babying them a little bit because ours are really are we're trying to make ours hardy, dry land style and drier climate seed too. So, kind of just let them, take their natural course by putting them in the ground too. But again, you can always give them that head start if you want to. And I also notice with some types of our corn that are used to dryland style, they might mold in the ground because that's might be an excess amount of moisture, but that's kind of more only like Southwest specific seeds that I've seen so far.